Okay, Algebra 2, now we're going to talk about geometric series. Remember that a geometric series is the sum of a geometric sequence, just like an arithmetic series is the sum. You're adding them all up, so your answer is just a number. It's not a list anymore. And this is the formula that we're going to use for a geometric series, where n equals the number of terms that you're adding up, and a1 is the first term, and r is the common ratio. So as long as you have those things, we can find this. Remember that when we did arithmetic series, you had to know the first term and you had to know the last term. Now you don't need to know that, you just need to know the first term and the r, and how many there are. So let's look at some examples. Number 1, okay, these are all geometric, we don't have to check. So we're looking for n is 14. That's how many terms we're going to add up, because it asks for S14. A1 is 4, and R is 5. Okay, so we're going to find S14, and we're going to use this formula up here, and we're going to say A1 times 1 minus 5 to the 14th power over 1 minus 5. And this is going to be a huge number, because that is going up by a lot of, it's multiplying by 5 each time. So it's going up very quickly, and so when we add 14 numbers together, it's a big number. That's our answer. So let's look at number 2. We're looking for n equals 20. A1 is 81, and R is 1/3. So S20 is A1 times 1 minus 1/3 to the 20th power over 1 minus 1/3. And if you put all this in your calculator, you should get 121.5. Okay, look at number 3. This one is a little different. It doesn't tell us what n equals. It tells us the first terms, and then it tells you you want to add them all up till we get to this term. So we're going to have to figure out which term this 6,144 is, how many terms that is. So we're going to use our formula. Remember that for a sequence, it's this, and for a series, it's this. They're very different, and this one has n minus 1, and this one just has n, so don't get those confused. So we know that A1 is 3, and we know that R is 2, but we don't know what n is. So we're going to have to use this equation right here to find n. So we're going to say the last term equals the first term times R to the n minus 1. And we're going to solve for n, and that's going to tell us what term that is. So we're going to divide by 3 here, and we'll get 2,048 equals 2 to the n minus 1. So there's a couple things you can do here. We can solve this exponential equation by using logs. We've done that before, but n has to be a whole number. So this, you know that this must be 2 to some power. So you could just figure that out. And if you do, this is 2 to the 11th power. So that tells us that 11 equals n minus 1 and n equals 12. So this is the 12th term. So now we can find S12 and put a 1 times 1 minus 2 to the 12th over 1 minus 2, and this gives us that. Okay, it's a little bit tricky, but that's what we got to do. So let's look at number 4. 4 is the same way. 4, negative 12, 36, negative 108, all the way to 2916. All right, it's going back and forth between positive and negative, so that tells you that R is negative. A1 is 4. R is negative 12 over 4, which is negative 3. And we're going to use this equation to find which term this is, so we know what n is. So we're going to say 2916 equals A1 times negative 3 to the n minus 1. Divide this by 4, and we get 729 equals negative 3 to the n minus 1. So this must equal negative 3 to some power, and you can figure that out and get that that's to the 6th power. So we know 6 equals n minus 1, and n has to equal 7. So this is the 7th term, and we're looking for S7 then. So we're going to take a 1 times 1 minus negative 3 to the 7th power over 1 minus negative 3. Make sure you got all your parentheses and everything in there. And this is going to equal negative 2188. All right, let's look at some summation notation. If we have the sum of n goes from 1 to 25, of 2 to the n minus 1. All right, this is R, and whatever number is right here is A1. Since there isn't a number there, that tells us that A1 equals 1. And this is n. So we can just say S25 equals A1 times 1 minus R to the nth power over 1 minus R. And this again is a really big number. Geometrics are usually really big. Okay, number 6. We got the sum of, I can't even see what that, is it x? X equals 1 to the 8th power of negative 32 times negative 1/2 to the x minus 1. So this is R, this is A1, this is n. So we're looking for S8, which is A1 times 1 minus that over 1 minus that. And this equals negative 21.25. Now, number 7 and 8 are different because they don't start with a 1. The summation, we have k equals 6 to 20, negative 4 times negative 3 to the k minus 1. So we have to figure out, there's R, okay? And we have to figure out what n is. N is this 20 minus 6 plus 1, which is 15. Okay, you always have to add 1, because look, for the one above it where we went from n equals 1 to 15, and we said n was 15, we didn't take 15 minus 1. That would have given us n of 14. You have to add 1 to that. So that's what our n is. N is 15, r is -3, but we have to find A1, and A1 is A1 is when k equals 6. So we take -4 times -3 to the 6 minus 1, and that should give us 972. Let me make sure that's right. We have -3 to the 5th power times -4 is 972. Yep. So that's our A1. So this answer right here, the SN that we're looking for, is 972 times 1 minus -3 to the 15th power from there over 1 minus -3. And this, again, huge number, and you get that. Okay, number 8, same kind of thing, summation. M equals 2 to 11 over, or times 81, 1/2 of m minus 1. So r is 1/2, that's easy, that's right there. N is 11 minus 2 plus 1, which is 10. And our A1 is when m equals 2, so it's going to be 81 times 1/2 to the 2 minus 1, which is 40.5. And our SN is 40.5 times 1 minus 1/2 to the 10th power over 1 minus 1/2. And this equals, well, I'll let you know what the actual fraction is if you wanted to figure that out, but that is approximately 80.9209. All right, that is a geometric sequence or a geometric series that is finite, that has an ending, but we have some infinite geometric series. Okay, on this next page, we have 1/2 plus 1/4 plus 1/8 plus 1/16 plus ... It's going on forever. S1 is 0.5. It's just 1/2. S2, if we add the first two together, we get 0.75. If we add the first three, we get 0.875. The first 4, 0.9375. 0.96875. Up to S6, we get 0.984375. And I'm going to tell you that as we go to infinity, as n gets bigger and bigger and bigger, and we keep adding more numbers, this is going to 1. This number is going to get closer and closer to 1, and it's never going to reach it. The other series we have here is infinite, and S1 is 0.5. We start with this. S2 is 1.5, then 3.5, then 7.5, then 15.5, then 31.5. And as we go up to infinity, this is going to infinity. Okay? If the series approaches a number like this one, it's called convergent. And if it approaches infinity, it doesn't approach a certain number, it's called divergent. And how do we know? Okay, what is R equal for this one right here? R is 1/4 over 1/2, which is a half. And over here, R is 2. So the way you know if it's going to be convergent or divergent, if the absolute value of R, because it doesn't matter if it's positive or negative, it's just the value. If it's less than 1, then it's convergent. And if the absolute value of R is greater than 1, then it's divergent. If it's greater than 1 and it's divergent, we can't find the sum of an infinite geometric series if it's divergent. Or the sum, we can just say the sum is infinity because you're just keeping it to add. But if it's convergent, we have a formula to use. So to find the sum of a convergent infinite geometric series, we're going to use the formula this. Okay, and the difference between this and what we just did on the other page is here n is infinity. This is an infinite geometric. On the other page, when we used this, n was a number. It ended. The series ended somewhere. For this one, the series never ends. It goes on and on and on, but we can only do it for a convergent. So let's look at number 9. It says, first of all, determine if it's convergent or divergent, and if it is convergent, find the sum. If it's divergent, then you're done. So for number 9, these are all geometric, so we're gonna say 1/4 divided by 1. R is 1/4, so yes, it's convergent because that is less than 1. So we're going to say Sn is 1, A1, times 1/1 minus 1/4. And that equals 4/3. And that is your answer. All right, number 10. If we take 8/3 divided by 2/3, we get 8/2, which is 4 for R. So no, this is divergent. We're done. We can't find the sum. The sum would be infinity. Okay, number 11, we'll say R is 3.48 over 5.8, which is 0.6. So yes, this is convergent. And we're going to say the sum is A1 times 1/1 minus 0.6, and that equals 14.5. Number 12, R is -96 over 128, which is -0.75. So this is convergent. And we'll say A1 times 1/1 minus -0.75, and that is 512 over 7. Number 13 is a summation notation. So we got x equals 1 to infinity of -2 times 1/4 to the x minus 1. So there's our R right there. It's less than 1, so this is convergent. And we can say Sn equals, there's A1, -2 times 1/1 minus 1/4. and that equals negative 8/3. Number 14 is convergent. Just by looking at it, R is 0.8 and A1 is 7, so we get 7 times 1 over 1 minus 0.8, and that equals 35. And the last two where we don't start at a 1, number 15 is divergent because R is negative 5/2, and that is, the absolute value of that is bigger than 1. So we're done. Number 16 is convergent, and let's see what we got to do. Let me write it out here. We got K equals 2 to infinity of negative 6 times negative 3/4 to the K minus 1. So this is R. And we have to find A1 is when K equals 2. So we're going to say negative 6 times negative 3/4 to the 2 minus 1. And that equals 9/4. Because that's negative 6 over 1 times negative 3 over 4, which is negative 18 over 4. Is that right? What did I do wrong? I think it's 9/2. Let me see. 0.75 times 6. Yeah, this should be 9/2, not 9/4. And that should be positive because they're both negative. So then we say Sn equals 9/2 times 1 over 1 minus negative 3/4. So that is 7/4 down here. So that becomes 9/2 times 4 over 7, which is 18 over 7 for your answer. And that is the end of this section.